Okay, solutions to system. What's a system of equations? We've done these before. What's a system?
X and Y.
Well, what's a system of equations? It's two or more equations, right? That both have to be true at the same time. You remember when we checked to see if an ordered pair was a solution to a system, you had to check it in both? So this part's just going to be a review. So we're going to do this real quick, and then we'll do 5-2, which helps us solve these things. So exercise 1, we ought to do this, right? Determine if 2, 5. And that's an X. Is that color? That is an X. Yep. X comma Y, right? So we plug it into the equation for the X's and Y's in there, yes? So we check it in the first one. Y equals 4x minus 3. What do I put in for Y? 5 equals 4 times 2 minus 3. 5 equals, wait.
5 equals 5.
What did I do here? Oh, yeah, that's it. Never mind. Does 5 equal 5?
Yeah.
That's how you check it, right? So it is a solution to the system?
Doesn't the other one have to be?
Yeah, we don't know yet. We got to check both of them, right? So let's check this one. 2 times 2 plus 5. That might equal 9.
Yeah.
Does 9 equal 9? So yes, it is a solution. About the second one. What are we going to? 5-1.
You're just plugging in. Oh.
Plug it in. Yeah, this part's review. We've done this several million times. So let's check this one here. Y minus X would be what?
5 minus 2 equals 3. 3 equals 3.
So yeah, 3 does, whoops, 3 does equal 3. Yep, look at this
5
thing.
equals 1. 2 plus 6.
And then the other one, so we'd have 5 equals 1/2 of 2 plus 6. What's half of 2? 1, right? Yeah.
5 equals
5, does it?
No. No.
So this is not, it's not a solution to that system. Okay? So you when I do this, you copy it down in there, right? So that's what you have for reference. Right? Okay. So we can also solve systems by graphing them, can't we? And they're talking about it. We'll get to the calculator stuff soon enough. But when we graph two equations, where do we find their solution? Maybe if we graph two equations over here, where do I find the solution to them? Were the two graphs what? Amy? Well, one's probably going this way, one's probably going this way. Where will we find the solution? Where will the graphs be the same? Were they?
Intersect.
Thank you, Amy.
Thanks, Amy. Yeah, no problem.
Right? So like up here, if we were to graph these two equations, where would they, at what point would they intersect, these two equations? They intersect at the coordinates 2, 5, right? So let's go down here and do that with these. So this one here, let's graph it. What's the slope? What's the m? 2, right? And what's the y-intercept?
5.
Or that.
B equals B, yeah.
So 1, 2, 3, 4, 5. Which way do we go? Well, it's hard to go up 2, right 1. So couldn't we make it 2 negatives? Down 2, left 1. Thank you, Tegan.
I got you.
Okay, instead of going up 1, right 2, we could do equivalently go down 2, whatever I said, the other way. So down 2, left 1, right? Isn't that the same as up, over, right?
Yeah.
Like that, right? And then you get your straight edge out, right?
Oh, oops.
Double arrow that thing. And oh, I missed.
I'm so confused.
Oh, I shouldn't have put a point there. That's why.
You see where it says no. That's you can't go up, so we're going down. Oh.
Instead of going up 2, right 1, I'm going down 2, left
That makes more
1.
sense.
Because two negatives, right, make a positive.
Yeah.
Okay, so try and be accurate, right? Like if you're going to solve by, listen, hey, if you're going to solve by graphing, you want to be accurate, right? With a straight edge and be real careful because you're looking for the intersection point. You want that to be accurate. What about this one here? What's the slope of this one? Let's rewrite it. Whoops. How about y equals negative x plus 2? It looks like what it needs to now, right? What's the slope of this one? Negative 1 over 1, right? Rise over 1. And what's the y-intercept? 2. So let's put on 2, and then go down 1 over. So basically just going to keep doing that, right? So I'll just do that. I'll get a point down there. Yeah, let's get our line in here. So from here. Well, see, that was supposed to be an arrow. This thing is really... Now there's no arrows on it. It should have an arrow, right? But you know that. Okay? All right. Amy, you see where those two graphs intersect? Right there? Why? I don't know. Maybe it's all relative because I'm so smart, the board just seems a lot dumber.
We.
Amy, what are the coordinates of that point where they intersect? Negative 1, comma 3. Right? So let's write that down. Negative 1, comma 3. So let's verify that algebraically, right? Let's see if when we plug that into these equations, it actually works. So let's start with the first one. Y equals, look, what's going on?
Equals 2, negative 1, plus 5.
Does 3 equal negative 2 plus 5? I'll bet it does. And we have to check the other one. Y equals 2 minus x. So 3 equals 2 minus negative 1, right? Which is the same as what?
Plus 1, 2 plus 5.
So it is a solution algebraically and it's a solution graphically. Yeah? But we've done this stuff before, right?
Yeah.
Okay. Let's move on. Graphs of equation. Yeah, we just covered that, right? Yeah, I'm recording. So a point, that's a graph equation. Makes it so any point, when you graph a line, by the way, it's made up of an infinite number of x, y pairs, right? Wouldn't you agree?
Yes.
That's a good guess. Not just the integer x, y's, but all the decimals in between, right?
Yeah.
And every point on that line would be a solution to that equation, wouldn't it? Yeah, okay. That's all they're saying here. So let's see here. So now you can put the definitions in. This is simple. So number one, fill in the blank. To solve a system of equations, graphically, you find the what? Intersection of the two graphs. Number two, this works because any intersection point must lie on both graphs. Number three, because intersection points lie on both graphs, they must make both equations true. Oh, and now we're cooking with gas. It's like I got the Valley chorus out here.
Chorus.
They're all in unison there. Singing together. Because intersection points make both equations true, they are what to the system?
False.
Solutions.
Because they're true, they're false.
What? Yeah. Who said that?
Hereditary.
Okay. All right. Let's go down to exercise 4. Janelle and Swetha. I guess that's a name.
They are just making names up at this point.
Sarah and Betty are taking a 50-question true-false test.
It says
I know.
Janelle
Janelle started after Swetha. Why? Had already finished 12, so Swetha, I can't stand saying it. It's just so contrived.
No, I love that name.
Yeah, it's not about the name, it's just about the fact that they try to contrive it to, like, if there's any Swethas out here, they feel included.
I've never seen my name.
Anyway, so Janelle started after Swetha had finished 12 questions. So are they starting at the same point? They are not. So Janelle answers questions at a rate of 2 per minute. Does that sound like a slope? Yeah, 2/1. Swetha answers at a rate of 5 questions every 4 minutes. Does that sound like a slope? 5/4, right? So Janelle eventually catches up. How many minutes does it take her? Now we have to realize about the way they set this graph up here. Notice the x-axis. It's a number of minutes, M, since Janelle started. Okay? And questions answered. So Janelle started last, right? Okay. So maybe we put, create 2, let's make the linear models, okay? Let's do Janelle. What was her slope, Janelle?
2/1.
Yeah, 2/1 either, right? So if we're going to use, let's use J for Janelle's variable, number of questions, right? And M for, this is going to be the confusing part, right? Because M is slope, and they want you to use M for minutes, so please don't get confused there. You guys follow me? So her equation would be, if J is the number of questions she's answered, it would be what? They're going to use M, not for minutes, like instead of X, okay? And of course, she starts at what? 0. All right. Now, Swetha,
started at 12.
what is Swetha's slope? Yeah, that's true.
But you spell it.
Does not even matter.
It doesn't.
5/4. Now she has a y-intercept of what, Tegan?
12.
12 questions already answered, right? Okay. And by the way, what's Janelle's y-intercept? No, that's her slope. 0, right? Plus 0. So we're going to do the same thing again. Let's graph Janelle. So she starts here at 0. And what's her rise over 1? Run? Her y's over 1? Up 2/1, right?
Oh, yeah,
Let's be careful now. What are they counting by here?
Oh.
Yeah, be careful.
They're counting
By 2s. So it's going to look like up 1 over when they're doing 1s here, right? Got to be always check that. So like here, there, just keep out right up the line here. So now we just get our straight edge.
Oh, wait, no,
Start like that, yeah.
Is this going to have arrows at the end?
Well,
No, because it's only going to 50 questions.
yes, the answer to that is yes and no. Because it's a 50-question test, right? But what is the maximum? Look at the
It's
y-axis.
40.
Yeah.
So, yeah.
So there will be an arrow. Why?
It's because you're getting... I don't know. You're getting fussy with the board.
I'm about to get, it's going to get, this board doesn't even know fussy yet because it's about to happen. Yes. It was a threat.
Yes.
Well, it's like all the stuff I have to accomplish in my day, and then, like, why? You know?
Why? He's asking himself why.
All right, so that was Janelle, right? All right, let's do.
Wasn't today.
So, this other female. So she starts at what? 12, right? Now be careful. We got to go up 5 and over 2. Or over 4, right?
Why do we have to go up 5 if we're only times by 2?
Because it's
It's 5. They're trying to make it more complicated.
not that much more.
No, don't.
So 5 is only 2.5 square. Oh, you want to, how about this? We didn't do her equation, right? What her equation would be S equals 5, fourths x plus 12. But hey, do you want to count like even number? How about, wouldn't this be 10/8?
Wait, isn't it M, not X, because we're going by minutes?
Yes.
Yeah, I'm sure have to get on the game.
I hope you feel good about that.
I do, I feel real good.
How about, wouldn't 10/8 be the same as 5/4? Now you don't have to count half blocks if that works better for you.
Oh my God,
Okay.
I did the half blocks for the.
Okay,
You
well,
can, but.
I'll go up 10,
What's the plus?
oh, from here. So 12 plus 10 is 22, and then over 1, 2, 3, 4, 5, 6, 7, 8. So like that. Right? Yeah. And I'll just use my straight edge there. We'll see if I'll use my straight edge.
After this ruler doesn't have the name on it.
Oh, well. Oh, no.
That's a federal crime.
That's grand larceny is what that is.
I hope you're not trying to do that line. Okay.
He's had enough.
Clearly. No, this is a lesson in perseverance, kids. This is going to be a lesson to you. I'm going to handle this really well because I want to be a model, role model to you. I don't want to be a model. I want to be a role model.
Why
I'd probably make a lot of money, obviously, if I was a model. Right?
You make something.
Why are you holding her back at the board?
Why not? Yeah, all right. I'll get picky. All right. Well, so what? Like, I don't know. It's like, all right. So we have an intersection point up there, right?
Yeah.
See that right there?
Sure.
So what is that? What are the coordinates of that intersection point?
Give me a second.
Oh, oops.
What comma what?
17.
No.
It's a number, I know that.
8,
34.
32. Oh,
Eight.
that's wrong.
Wait, what? 1634. No. Wait.
16. Looks like 17. Did we get that right?
Yeah, I said 17, you said no.
Well, because I had 16 here. I wonder if my graph's a little off.
My God.
Looks like 1732. So that means, what does this mean, 1732?
But isn't it something? The side is.
For up here? Well, that's 34, actually, isn't it? So this would be 34. I wonder if I get this inaccurately here. Let me just see. So this is all review, yeah? Hey, so if a point is a solution to a system, it has to make it both true algebraically. And if you graph two lines, where do you find the solution? The two lines what? Intersect. Let's look at the Regents question.
There's so many Regents questions.
Yeah.
It's not really.
Let's read this one about Serenity Conklin. Which statement best describes, I mean, let's just hurry. Solution of a two-variable equation.
It's number 3. No, it's not 3 or 4.
Why would they have to have 0 for one of the coordinates?
I don't know. I just guessed.
If a point's a solution,
must lie on the graph.
does that have to lie on the graph?
Yeah.
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 Yeah. So just like know that from here on out. Okay? All right. So that was
We're doing 2 lessons?
yeah.